Jai Jinendra, Namaste and welcome to my channel. Today we are going to solve the 43rd question of the problem solving series and the third question of stack data structure. The difficulty level for this question is medium and this question has been asked in Facebook, Google, Amazon, Microsoft and Uber. So let's begin. Simplify path. So we are given an absolute path. We need to determine its simplified canonical path. So this absolute path can contain anything, right? Like we know that if you see this example, so here a canonical path always begins with a slash. So our answer will have the simplified canonical path will always have slash, but in this absolute path you can have double dot, which means the previous directory. Assume this is a file system. We have a file and we have input of the path, absolute path. So we have this slash home, then double slash, then few folder and then slash. So this double slash doesn't mean anything, right? It means a single slash only. So you need to know that this slash, the double slash doesn't mean anything. It's a single slash. That means the directory will be changed. So for this, the answer would be slash home slash foo. And at the last, there is a slash which we don't add in our simplified canonical path. In the second example, we have slash home slash user slash dot dot slash picture. So we know that the dot dot means we go to the previous folder, right? So for this one, our answer will be slash home. So slash users, then dot dot, that means it goes back to home and then it goes to pictures, right? So this would be the answer. So it goes to home, it goes to, we go to, from home we go to the user folder and then we again go back to the home folder and then we go to the pictures folder. So if it exists. So this would be the absolute canonical path. So we need to know that a double dot means a previous directory. We go to the previous directory. From users we went to home, previous directory, right? And if there is a single dot, that means we stay in the current directory. So if there was a single dot here, then the absolute path would be slash home slash users slash pictures. Okay, so same directory. And the absolute canonical path, the simplified canonical path will not end with slash. And if it is if we don't have any path, then if it's a root directory, then it will be slash. Otherwise, it won't be there. And what else? So we have covered all the rules of the simplified canonical path. So how do we solve this? How do we give the simplified canonical path when we have the absolute path given? What is the logic that comes to your mind? So we see that we remove extra slash, we remove the dots, we give the absolute simplified canonical path. So for example here, when we have this kind of string that we have, right? So we have this simplified path, this is the absolute path and we need to return the simplified path. So how do we solve this? When we have this string, how do we return this string? So if I insert all of this into a string, slash, so it always starts with slash, right? So we'll have a slash and then we see that, okay, we have a slash. Then we can ignore it because we already have a slash, or we can add it. But the point is, when we go to the previous directory, from users to the previous directory, we need to remove this. So to remove this, if we are adding it in the string, we need to remove this and then we go to this. So what do we think of? Like we are checking the previous thing, right? We are dependent on the previous entries and we need to remove the previous entries and we need to add the current entries. So which data structure would help us to do this operations? The stack data operation would be helpful for us to do this operation in optimized time. So if I take a stack, right? So we know this is a stack, this is a stack, okay? And now say for the second example, we have, we have the result as a string which you will return, okay? It will always start with slash. Now when we see a directory, what do? We enter it inside the stack. So this is home, okay, this directory. Now we can see that, okay, it's a slash. Okay, we are since it's a whole thing is a single string. So when we see the characters, okay, when we see that slash has come, that means the folder has been completed. We are going to the next folder, okay, or the file, anything. So whenever we see the whole string without dot dot and slash, we insert it into the stack. So home has been inserted. We see slash, we ignore that, and then we see users. So we again insert this into users, right? Now we see slash, we ignore it. But when we see a double dot, what does this mean when we have a double dot? So if we have a double dot, we are going to the previous directory. So if there is a single dot, we could have skipped it and we could have moved ahead. But since it's a double dot, so what do we need to do? We need to remove this from the stack. So we will pop this out and this will be empty and this is gone here, and then we go to the next folder, the entry without slash and dot dot. So next is pictures. So we enter pictures here, right? Now we have covered all of them. We have this entry in the stack. So whatever the entry is in the stack, if we reverse it, so we get our answer. So when we can reverse this stack, have another new stack, enter this, so the order would be changed. So there will be pictures, then there will be home, and then we have a result string. So slash home, and then when we pop it out, we add another slash and then pictures. So this will be our path, right? So I think the approach is clear now, the intuition, the logic. So let's start doing the pseudocode. What will be the time complexity for this? We will be traversing the string, we'll be adding it to the stack, and then we will reversing the stack. So it would be order of n plus n, and the space complexity would be, we'll be taking an extra stack. So the time and space complexity would be order of n. Okay. So let's look at the pseudocode. We take a stack, st, and we take a string, say dir directory, to get the directory every time we are traversing, and we will have a result string where we will return the answer, and say int of n is our path, the size of the string that we have as an input. So let's traverse the string for I equal to 0 to n. Okay. Now whenever we see that if we see that the element is, the first character is slash, whenever we see in the path, so what do we need to do? We need to ignore it, right? And we need to have a string result insert assigned as this, because if there is no element, then we'll be returning this, right? Since it's a string, so I'll have a double quote. Okay, and we'll be returning this result, okay, at the end, right? So let's concentrate here. So if we see that we have any string, say like this, like this, three things. So we need to ignore this, right? So whenever we see this, we will increment our I. Fine. If we see that this is not there, then what we do? If path I is not equal to this, right? Then if our path I is not equal to this, then we can append the value of the path I every time, right? And once this is appended, I plus plus right? So we get our path, right? Say if this is the one, so firstly we will ignore this slash, and then suppose for here in here when we are in this path, so we get 2 slash, so we'll ignore this 2, and then we get FOO. So this FOO will be added to directory, and then when we get when we get again this slash again, so we'll ignore it, right? So in this way we'll have our this path, this directory. So we have our directory now. So after once we get our directory, what do? We need to insert it into our, so for now we have traversed the one directory. So now we'll check if say if a directory is equal to compare dot dot, and the stack is not empty, right? If stack is not empty and directory dot compare is dot dot, what do? We will pop out the element which is present in the stack, right? For example, here in this case, if we get this in the directory, okay, so every time are we okay, so whenever we are in the loop, so here whenever we are traversing, so every time we will be adding on the directory, so from home and food, so it will be appended every time, right? So once this operation is done for once here in the this one traversal, in this 2 case we get a folder, so then again we'll get another folder. So before getting the another folder into the directory, we need to clear whatever is there in the directory, okay? So this will clear our directory string, okay? Now I'll dry run it once I code it, so then it would be more clear. So this condition is done. If directory.compare is dot dot, then and stack is not empty, then we'll remove the element from this stack. Else if directory.compare is equal to single dot, then what do? We continue, because that is in the same directory, okay? Else if directory dot size is not equal to 0, then what do? We push the element directly into the stack, okay? So this is done. So now we have our stack with the directories. After this, let's code it over here because we don't have enough space. So what do? Or I can actually okay, I can clear this and code it over here probably. That would make more sense, right? So if I remove this, okay, so once this is done, I'll take another stack, okay? I'll just pseudocode it, stack string st1, and I will insert all the elements that are there in this stack into the stack st1. So we will get the reverse of the stack, right? So I'll just write the steps here. We can discuss it with the code walkthrough. So I'll code it, no problem. So what do I do? For while stack dot empty, not stack dot empty, what do? st1 dot push st dot top and st dot pop. So in this way we have reversed the entries of the stack. So we have put the stack entry into the stack 1, and so whatever the entries are there in the stack 1 is the reverse of the stack. So now we have this, and now what do? We traverse stack 1. Okay, so while stack 1 dot empty, while this stack 1 is not empty, Then what do? We add so result plus equal to, or result dot append equal to st dot top, st1 dot top, right? And then we st1 dot pop, and then what do? If the stack st1 dot size is not equal to 1, then we enter st1 dot then we insert result plus equal to that slash. Okay, I'll explain this what I've done here, and then we close it and then we return the result. So the thing is, so here we, after adding the string, right, here home, so slash is there in the result, I have added home, then again I need to add slash because slash is not there in the stack. So I'll add slash when the stack size is not equal to 1. Okay, why? Because if stack size is 1, so here after that, so after popping out, okay, so for example here home slash users, so we have this home and pictures in our stack. Okay, so I've got the result as slash and then I see home in the stack. Okay, so I've added home. Okay, now I have popped out the stack, popped out the entry from the stack. So what is the size of the stack? So stack only has, so this is not equal to, stack only has pictures, right? So the size is 1. Okay, so I can add this will be equal to 0. Okay, I can add this and I can add pictures. Okay, since slash is there, yeah, home, then slash should come, and then when I see what is the at the end, pictures, so I add pictures, but I will not add slash because we can't end it with the slash, because and the size of the stack is 0. So in this way we'll get our answer. Okay, I hope the explanation is clear. The link to the question has been given in the description. Please try it yourself and then come to my code walkthrough section. Here is the code walkthrough of the 43rd question, simplify path in the LeetCode platform. So you can see this questions has been asked in multiple companies: Facebook, Google, Amazon, Microsoft, Uber, Oracle, TCS. Okay, so we already discussed the question. You can see what are the conditions here. You can see the link in the description section of this question. So let's see the code. So I've done the same thing. I've appended here. I'm going through this. I'm clearing the directory and I am going ignoring this slash, and then if I don't have slash, then okay, while I has to be less than path dot size, this condition has to be there, otherwise we will cross this and will not get the element. So this condition needs to be put before this. Okay, and then we enter the characters in the directory, and then we see what does directory contain. If it compares dot dot, we will pop this entry from the stack, and then if it is dot, we will ignore. If it is, its length is greater than 0, then we will push that directory into the stack. And once we are done with this, we will just reverse the stack entry by taking a new stack st1, and then we will add this into a result string. Okay, if the size is greater than 1, then if not, it is not equal to 1, we will add it with a slash. Otherwise we will not add with, if it is if the size is equal to 1, that means this is the last element, so we will not add this slash and we will just add the temp and then we'll return it. Okay, so just let's submit this directly. So yeah, you can see it's accepted. Okay, so we'll discuss the 44th question in the next video. Jai Jayendra.